All right, this isn't actually page 2, it's number 9 from page 1. We're getting there. So let's see. Which graph best represents the relationship between the potential difference? So potential difference is V, is voltage, across a conductor, and the current through the conductor at a constant temperature. The reason why T is constant, why they're telling you that, why that's important, I guess, is that means R is constant for the conductor. And if R is constant, we know that V equals IR is our relationship. If we solve for R, it's V over I. And we've said this a few times. If you graph this, V over I is the slope. So if R is constant, this slope has to be constant. So the graph A is correct. Number 10 says, how much current flows through a 12 ohm resistor? So they give R is 12. Excuse me, not a resistor, a flash bulb. Same thing, it works the same way in terms of we're going to use V equals IR. They give you the voltage is equal to 3 volts. So pretty straightforward. 3 volts equals I times 12 ohms. So I is equal to 1/4 of a volt per ohm, which is an amp. So 0.25 amps. All right, number 11. In an incandescent light bulb is supplied with a constant potential difference. So V is constant. And they tell you it's 120 volts. It doesn't look like it's a numeric question, so you don't have to know that. As the filament of the bulb heats up, so as T goes up, we've talked about this, R goes up. But V is constant. So this is one part of your answer. So C and D both could be right because it's saying the resistance increases. The second part of the answer is what happens to the current. The current we get is Ohm's law. I is equal to V over R. If V is constant, that's not changing, but R is going up, our current is going to drop. The more resistance we have, the less current we get for a given voltage, and that's what we have here, so the answer is C. Number 12, in a simple electric circuit, they give you the voltage is 110. It draws, that's a heater, so it draws 2 amps of current. I is 2 amps. The resistance of the heater is, well, again, V equals IR, so 110 equals 2 times R, 55 ohms. All right, next question, this is 13. 30 ohm resistor and a 60 ohm resistor are connected as shown below. It's a series connection, so you have 30 and 60, and they're connected to a 12 volt source. Compared to the electric current through the 30 ohm resistor to the 60 ohm resistor, this is a softball question, no offense to softball players, I is constant in a series circuit, so it's going to be the same. Next one, 14, the diagram below represents an electric circuit consisting of a 12 volt battery, a 3 ohm resistor, R1, and a variable resistor, R2. Variable resistance just means R can change. It can be 10 ohms, it could be 20 ohms. These things, they have ranges to them. They might go from 10 to 1,000 ohms, who knows. In this case, they don't tell you what the range is. It could be anything, is all they're saying. Question says, at what value must the variable resistor be set to produce a current of 1 amp through R1? So if I redraw this, you have 12 volts here, you have 3 ohms that's known here, you have this variable resistor. This is the way it's drawn. It just means this R2 could be anything. But what doesn't change here is this is a single loop, so it's a series circuit. So R total is R1 plus R2. So it's 3 plus whatever our variable resistor is. Now, we know we want the amperage, we want I to be 1 amp, it says, through R1. So we want this to be 1 amp. We could call it I1, but in reality, it's I total, because there's just one loop. Whatever the current going through here is the same as the current going through here. It's the total current. So if we look at V total equals I total times R total, we're just going to keep reusing Ohm's law. V total is 12. We want I total to be 1 amp. R total has to be, when you do the math, 12 ohms. But we said over here, because it's series, R total is just the sum of the two resistors. If this one's 3, this one has to be 9 ohms. So the answer is D. 15. Last one on page 2. 15, again, is a series circuit, 2 8-ohm resistors. You have 8 ohms. 8 ohms, sorry, I'm not drawing so well on the iPad tonight. You have an ammeter here, which measures current. You have a 12-volt power supply. And the question is, what's the reading on A? So A is measuring I total. But it's also measuring I1 and I2 and I whatever. For series, this is the rule. Now, to get I total, we're going to do the same thing we did the last time. We're going to do I total times R total is V total. V total is 12 volts. R total in series is just the simple sum of those two. So it's 8 plus 8, or 16 ohms. So I total is equal to 12 volts divided by 16 ohms. Divide this over to this side. So I think that's 3/4 of an amp, or 0.75, which is answer A. All right, on to the next page.